Welcome to Calvin's Online Maths. Let us solve this algebraic equation. So we have root of x plus root of x minus 11 is equal to 11. So let us just rewrite what we have. That is root of x plus the root of x minus 11 is equal to 11. So we want to start by removing these root signs. So you can do that by squaring both sides of this equation. So as you can see, the left hand side looks like a quadratic identity, that is a plus b squared, and this is normally given by a squared plus 2ab plus b squared. So we can simplify the left hand side of this equation using this identity. So we're going to have root of x squared plus 2 times root of x times the root of x minus 11 plus the root of x minus 11 squared, and that's equal 11. So 11 squared. So we have root of x squared, which is just x, plus 2 times these two roots, that will be 2 times the root of x into x minus 11 plus the root of x minus 11 squared is the same as 11x minus 11, and that's equal 121. So we can collect like terms. So we have 2x plus 2 into x squared minus 11x. Then we can take this 11 to the right, so that's equal to 121 plus 11. Then on the left hand side, you can see that 2 is common, so we can factorize so that we have x plus x squared minus 11x, and that's equal to 121 plus 11, which is 132. So at this point, we just divide both sides by 2 so that we have x plus the root of x squared minus 11x is equal to 132 divided by 2 is 66. So again, at this point, we have to get rid of the root sign. So we just take x to the right so that we have x squared minus 11x under the root sign is equal to 66 minus x. So we can get rid of this root sign by squaring both sides of this equation. So when we do that, the left hand side, the root will cancel with the square, but for the right hand side, we can see it is the case a minus b squared, which is given by a squared minus 2ab plus b squared according to the quadratic identities. So for the right hand side, the root sign and the square will cancel, so that we're left with x squared minus 11x, and on the right we're going to have 66 squared minus 2 times 66 times x, then plus x squared. So as you can see, we have x squared on both sides, so x squared and x squared will cancel, so that we're left with minus 11x is equal to 66 squared minus 2 times 66 times x is 132x. So we can collect like terms where we're going to bring negative 132x to the left. So we have minus 11x plus 132x equals 66 squared. So on the left hand side, we have 132 minus 11, which is just 121x equals 66 squared. So you can divide both sides by 121 to get the value of x. So x can be given by, so we can write 66 squared as 66 times 66 over 121 can be written as 11 times 11. So 11 here once, 11 here 6 times, 11 here once, 11 here 6 times. So it means therefore that x is equal to 6 times 6, which is just 36. So that is the solution for our x, that is 36. So we can check, we can verify that x is actually the true value in our equation. So remember, our equation was root of x plus the root of x minus 11 equals 11. So when we take the value of x to be 36, so you have root of 36 plus the root of 36 minus 11, and we want to check if that actually gives 11. So root of 36 is 6, plus here we have the root of 36 minus 11, that is 25, and is that really equal to 11? So 6 plus the root of 25, which is 5, is that equal to 11? So you have 6 plus 5, 6 plus 5 is 11, and that is what we have on the right hand side. So therefore means that our value for x is actually 36. Thank you for watching, and if you're new here, please support the channel by subscribing. Thank you, and see you in the next video.